Hello everyone and welcome back to another calculus video. In this video, we are going to review polar coordinates. We saw polar coordinates at the end of pre-calculus trigonometry, and we said back then that we could come up with formulas to represent rectangular in terms of polar by looking at some of those definitions. We know that cosine theta is equal to x over r, so if I solve that for x, I'll get r cosine of theta is equal to x. So now I have a replacement for x. And then we know that sine of theta is equal to y over r. So if I solve that for y, I'll get r sine of theta is equal to y. So that's where these two are coming from. X equals r cosine theta and y equals r sine of theta. We also know that tangent of theta is written as the y-coordinate divided by the x-coordinate. And so if we needed to find theta, we could take the inverse tangent of both sides. So we would get theta equals the inverse tangent of y over x. We do have to be careful. Remember, inverse tangents only defined in quadrants 1 and 4. So we're looking at values between negative pi over 2 and pi over 2. So if our y ordered pair was somewhere over here in quadrant 2 or in quadrant 3, we would have to figure out what theta value would be equivalent using reference angles. And then we know that a circle centered at 0, 0 is equal to the equation x squared plus y squared is equal to r squared. So if we know those pieces, we can convert back and forth between rectangular and polar coordinates. So let's look at a few examples. In part A, they're asking us to convert these to polar coordinates. The first one is the 0.11. So I'm going to think about where that point lives. That point lives in that first quadrant. So my angle would be the angle between the positive x-axis and the line segment that would connect 0.11 to the origin. So I know my y value is 1, and I know my x value is 1. So tangent of theta is equal to y over x. And if I take the inverse tangent of both sides, I'm going to take the inverse tangent of 1. And that's going to be pi over 4. Since this is in the first quadrant, that will be my theta value. And then I need to figure out what r is. And I can use x squared plus y squared is equal to r squared. I could also think about this in terms of the Pythagorean theorem, right? Because I would want to know this radius value. I know this side is 1, and I know this other side is 1, and both of those are legs. So I have 1 squared plus 1 squared is equal to r squared. So r would be equal to the square root of 2. So my ordered pair, which we're going to write as r theta, is going to be the square root of 2 and then pi over 4. B is asking us to do the same thing for the rectangular coordinates negative 3, 4. So I'm going to think about where that lives. Negative 3, 4 is in quadrant 2. So when I think about theta, I need to figure out what theta is from that positive x-axis. So that's my theta value. My x is a negative 3. The negative just tells me I moved to the left of the origin, and my y is 4. So let's start by finding r squared in this case. I know r squared is equal to x squared plus y squared. So r squared is going to be equal to negative 3 quantity squared plus 4 squared. So that's going to be a 9 plus 16, which is 25, and the square root of 25 is 5. So to figure out theta, we're going to look at tangent equals y over x. So that's a 4 over negative 3. So theta equals the arctan. And you could write that in two different ways. You could write arctan, or sometimes you see it written as tan to the negative 1. Now, this is not something that's on the unit circle, so I'm going to get a decimal representation. And I'm going to make sure I'm in radian mode on my calculator. So inverse tangent of -4/3 is about -0.9273. But remember, arctan's giving us something in quadrants 1 or 4 because it's defined between -pi/2 and pi/2. So we ended up with this value down here from the positive x-axis. That's what that -0.9273 represents, but we don't want that. We want the one that's in quadrant 2, so we're going to have to add pi to that to get that final answer. And if I add pi, I get about 2.2143 for theta. So my r theta values are 5 and about 2 point, I'll round up to 2 decimal places, 2.21. C is going to be similar. We're looking at the 0.03, so we're going over 0 and up 3. And we can see what this theta value is going to be. That's going to be pi/2, because from the positive x-axis, we moved up to the positive y-axis, and we moved 90 degrees. To find r, we're going to use r squared equals x squared plus y squared. X is 0, y is 3. So I'm going to get r squared is equal to 9, which means r is equal to 3. So my r theta values would be 3, 0. I just kidding, 3 pi/2. I just said that was pi/2. Sorry about that. And then if we look at that last one, they're wanting us to find an ordered pair in polar for 5 square root of 3 and -5. So if I look at 5 square root of 3, -5, it has a positive x and a negative y. So it's going to be down here in quadrant 4. So I got to figure out what my theta value is going to be. X is 5 square root of 3. That y coordinate's -5. Let's start by finding r again. So I know x squared plus y squared is equal to r squared. So I have 5 square root of 3 quantity squared plus -5 squared is equal to r squared. So when I square both of these, this is going to be 25 times 3 plus 25, and that's equal to 100, and the square root of 100 is 10. So I know r is equal to 10. So to find theta, I know tangent of pi over 3, tangent of theta is equal to pi y over x, and that's equal to -5 over 5 square root of 3, which is -1 over square root of 3, or we could think about it as negative square root of 3 over 3. I'm going to take the arctan of -1 over square root of 3, and this is where we're going to look at our unit circle. So if we look at our unit circle, we're going to be down here at 11 pi over 6. That's where that ordered pair is equal to square root of 3 over 2, excuse me, -1/2. So I take y divided by x, and I'll get that -1 over square root of 3. But remember, we want to write this in terms of -pi/2 to pi/2. So that's equivalent to -pi/6. So my r theta value is equal to 10 -pi/6. The next set of problems is asking us to go from rectangular, I said from polar to rectangular. So we just went rectangular to polar. Now let's go the other way. So E is asking us what is the rectangular form of the point when the point is 3 pi over 3. Remember that's equal to r theta. So we know x equals r cosine of theta, which is going to be 3 times cosine of pi over 3. And if we look at our unit circle, cosine of pi over 3 is the x-coordinate, which is 1/2. So that's going to be a 3/2. And then y equals r sine of theta, which is 3 times sine of pi over 3. Sine of pi over 3 is equal to square root of 3 over 2. So I'm going to get 3 square root of 2 over 3. So my xy ordered pair would be equal to 3/2 and 3 square root of 2 over 3. Or we could just write that as square root of 2. Oh, hold on. I've got 3 square root of 3 over 2. I am getting my numbers mixed up this morning. Sorry about that, guys. 3 square root of 3 over 2. So there's my ordered pair. F is asking us to find the ordered pair for 2 comma 3 pi over 2. So we're just going to do the same thing. X equals r cosine of theta and y equals r sine of theta. So x equals r cosine of theta equals 2 times cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0, so that's equal to 2. Y is equal to r sine of theta, which is 2 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so that's going to be a negative 2. So my xy ordered pair is equal to 2, negative 2. Just kidding. There's a lawnmower going in the background and it threw me off. Cosine of 3 pi over 2 is 0, so that's equal to 0 times 2, which is 2 for that x-coordinate. And then G. G is looking at the point 6 comma negative 5 pi over 6. So x equals r cosine of theta, which is going to be 6 times cosine of negative 5 pi over 6. Cosine's that x-coordinate. And that x-coordinate is negative square root of 3 over 2. And when I multiply 6 times negative square root of 3 over 2, I'm going to get negative 3 square root of 3. Y is equal to r sine of theta, which is going to be 6 sine of negative 5 pi over 6. So now I'm multiplying by the y-coordinate there. And the y-coordinate at negative 5 pi over 6 is negative 1/2. So my y-coordinate is going to be 6 times negative 1/2, which is 3. So my xy ordered pair is going to be negative 3 square root of 3 as the x-coordinate and negative 3 as the y-coordinate. So now let's talk about plotting points on the polar plane. How would we go about doing that? So we always start with the theta value. So we always start with the theta value. And then if r is positive, we're going to move along the terminal side of the angle that we're creating. If r is negative, then we're going to move along the side that's opposite the terminal side. So let's look at that first one. If I want to graph the point 2 pi over 4, my theta value is pi over 4. So if I look at this polar coordinate system, I've got a radius of 1 here, radius of 2 here, 3 here, and so on. Everything looks like circles. And then if I were to figure out what's going on with these lines that's extending out from the origin, we're starting at 0 here, and I've got 1, 2, 3, 4, 5, 6. So they look like they're going up by like 15 degrees. So this would be pi over 6, which is 30 degrees. This would be pi over 3, which is 60 degrees. And then this would be pi over 2, corresponding to that positive y-axis, which is 90 degrees. So this is 15 degrees, 30 degrees, 45, which is pi over 4, 60, 75, and so on. So if I wanted to label this, half of pi over 6 is pi over 12, and I could just think about going up by pi over 12. Pi over 12, which is 15 degrees, and then 2 pi over 12, and then 3 pi over 12, and then 4 pi over 12, and then 5 pi over 12. And then 6 pi over 12 puts me at pi over 2. So that's how I've labeled that. I'm just going to go around and quickly label the rest of this. Okay, so I'm back. So I've gone around and labeled everything by the 15 degrees, which is pi over 12. So let's see if we can find where these ordered pairs would live. And let me explain why they're plotted the way they are. So the first one is 2 and pi over 4. So from the positive x-axis, we're going to make that angle pi over 4, which is this line here. It's the one that divides that first quadrant in half. And then we want to move 2 out from that origin there. And because this is a positive radius, we're going to move along that terminal side. So that's why that ordered pair is where it lives on the picture. It's at 2 pi over 4 right here. The next one is -3, 2 pi over 3. So we're going to start by going 2 pi over 3 units. So 2 pi over 3 would be over here. That's in that second quadrant. So here's my theta value, but notice my r is negative here. So what that means is we are going to extend that side out. This would be the terminal side of the angle. I don't want to move along the terminal side because my r is negative. But if I extend that out, notice I'm creating a line, and this would be 180 degrees. I'm going to move along that terminal side 3 units. So 1, 2, 3. And that point ends up living in that fourth quadrant. And then let's look at that last one. I'm looking at the point 4, 5 pi over 4. So 5 pi over 4 is down here. So here is my angle, theta. Because r is positive, I'm moving along the terminal side. And that I'm going to move 4 units along that terminal side. So that point's going to end up in quadrant 3. Let's look at a few more. That next one under try it number 2 is asking us to plot 4, 5 pi over 3. So we're going to start with 5 pi over 3. 5 pi over 3 is here. So my angle is this guy. It extends from that positive x-axis all the way to that fourth quadrant. R is positive, so we're going to move along the the terminal side. So here's where my point's going to live in quadrant 4. So I'll label this as the point 4, 5 pi over 3. And then that last one is asking us to plot -3 and -7 pi over 2. So notice that that theta value is negative. That means we're going backwards around the circle instead of going the other way. So I'm starting with that positive x-axis. Now I'm going I'm going in this direction, which is clockwise. Sorry, I had to make sure that I was recording. I thought I accidentally hit the button. So we're going negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2. So negative 7 pi over 2 correlates with the line pi over 2. But because r is negative, we're going to move along the opposite side of the terminal side. So we're going to move down that negative y-axis 3 units. So our point's going to be on the negative y-axis. So there's our point, negative 3, negative 7 pi over 2. So the best way to graph if you're doing this by hand is to pick some theta values, plug it in, figure out what your R values are going to be. So I'm going to pick 0, pi over 4, pi over 2, 3 pi over 4, pi, and then I'm going to go with some other values in the third and fourth quadrants, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. I'm going to see if that's enough to create what my picture is going to be. So when I plug in those theta values, I'm going to get R values. And then I'm going to plot them. So the first one is 0, 0. So my theta is 0, and I'm not moving along the terminal side. That's going to be at the origin. And then at pi over 4, I'm moving 2.8 units along the terminal side. So here's pi over 4. That's moving almost 3 units. Pi over 2, I'm going to move 4 units. 3 pi over 4, I'm going to move 2.8 units, and then pi, I'm going to move 0 units. So you can see how that graphed that circle. So then what's going on with these down here? So at 5 pi over 4, I was at negative 2 square root of 2 when I plugged that in to figure out my r. Remember, r is equal to 4 sine of theta, so I'm looking at 4 sine of 5 pi over 4. And that's going to give me a negative value. So here's 5 pi over 4, but remember, because that r is negative, we are moving along the side opposite the terminal side, which puts us right back at this ordered pair, which we also called pi over 4, 2.8. And the same thing's going to happen for all the other ones. The next one is 3 pi over 2. So here's 3 pi over 2, and r is negative, so we're going to move along the side that's the opposite side. So you can see what's happening is that we're tracing the circle twice. If I look at everything from 0 to 2 pi. Now we could also graph this in Desmos. You go to Desmos and you type in your r equals 4 sine of theta, and that would produce it as well. Or we could do this in the calculator. But by hand, you pretty much have to look at just plotting different points. So what if we wanted the rectangular version of this? Well, we would use our substitutions that we know. We're starting with r equals 4 sine of theta. I'm going to multiply both sides by r, so I'm going to get r squared equals 4r sine of theta. I know r squared is equal to x squared plus y squared, and I know that r sine of theta is equal to y. So I've got x squared plus y squared is equal to 4y, or x squared plus y squared minus 4y is equal to 0. And if we complete the square on the y's, I'm going to take half the middle and square it. Half of 4 is, half of negative 4 is negative 2. Negative 2 squared is positive 4, and I would add 4 on both sides. So when I factor this, that's going to be x minus 2 quantity squared. So we can see this is a circle, and the circle is centered at 0, 2, with a radius of 2. So let's look at a few more. Let's say we want to rewrite each of these into XY notation. So going back to rectangular form. A says we're looking at theta equals pi over 3. So I'm going to start by taking the tangent of both sides. Tangent of theta is equal to the tangent of pi over 3. I can find the tangent of pi over 3 using my unit circle is the y value divided by the x value. And if I do keep change flip, I'm going to get square root of 3. Tangent is y over x. And if I multiply both sides by x, then I'm going to get the line y equals square root of 3 times x. B is looking at r equals 3. So if I square both sides, I'm going to get r squared equals 9. R squared is the same thing as x squared plus y squared. So I'm going to have a circle centered at 0, 0 with a radius of 3. And C, we've got r equals 6 cosine of theta minus 8 sine of theta. Let's multiply everything by r. So we're multiplying both sides by r. And when I distribute on the right, I'm going to have 6r cosine of theta minus 8r sine of theta. You just have to figure out, what do I do to get back to those things I know? X equals r cosine of theta. Y equals r sine of theta. X squared plus y squared is equal to r squared. And tangent of theta is equal to y over x. So it's just manipulating what you have to force it into one of these substitutions. I know r squared is x squared plus y squared. And I know r cosine of theta is equal to x. And r sine of theta is equal to y. So I'm going to have x squared plus y squared equals 6x minus 8y. So let's move all the x terms and the y terms on the same side so we can complete the square. So I have x squared minus 6x plus y squared plus 8y is equal to 0. So I'm going to take half the middle and square it. Half of negative 6 is negative 3. Negative 3 squared is a positive 9. So I'm going to add 9 on both sides. And I'm going to do the same thing with the y's. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 on both sides. And then I can factor the x group and the y group. The x group factors into x minus 3 squared. The y group factors into y plus 4 squared. And that's going to be equal to 25. So we have a circle. The center of the circle is at 3 and negative 4. And the radius is 5.